Hello and welcome to Enterprise Security Monitoring with Security Onion. My name is Wes Lambert, and I'm a principal engineer with Security Onion Solutions. At Security Onion Solutions, we help to develop, maintain, and implement Security Onion for customers. And I just wanted to share today how you can leverage from Security Onion, or how you can leverage Security Onion to get better visibility into your network environments, and just increase that overall detection coverage you have in your environment. So without further ado, let's talk about a little bit about what Security Onion is, right? So Security Onion in general it's a distribution that's been around for quite a while now. It's an open source or free and open platform really for threat hunting, enterprise security monitoring, and log management. And what that means is, you have things like IDS, like Suricata or Snort. You're triggering IDS alerts, or you're reviewing those IDS alerts. You're monitoring your environment for signs of intrusion and other suspicious activity. And then, if you have other log sources that you want to keep alongside that for compliance purposes or for other purposes, you can absolutely do that with Security Onion. So today is really just talking about all the components that are within Security Onion and how you can leverage those to really help your detection strategy and help your blue team, right? So continuing on to what it is, there are lots of layers of flavor within that Security Onion. We have audit authentication logs maybe that you might be pulling in from the cloud, or you may be performing traffic mirroring in the cloud. There's a lot of capability there now with things like, or environments like GCP and in AWS. Azure, not so much at the moment, but there's a lot of good stuff there that can be brought in from the cloud into either your on-prem or in-cloud Security Onion sensor. In addition to that, server logs, application, or maybe things like DNS logs from servers or DHCP logs, as well as Windows logs and host logs, right? Sysmon logs. We can bring those in from servers and from hosts, and then bring those into Security Onion to help, from that detection and that log management capability perspective. In addition to, really the most popular, I think, is the traffic mirroring that, we have coming in via a spam port or a tap. You can feed Security Onion with that data and see exactly what's going on the wire, right? So a lot of visibility there and a lot of value there with Security Onion. So why use it, right? So we can collect all this data. We have all these ways or this data that we can bring in. Why would we use Security Onion? I talked a little bit about detecting threats, right? Detecting threats within your environment, hunting for bad guys. A lot of times these IDS rules that we have, they're not going to be the end-all be-all as far as figuring out what's going on in your environment and alerting on suspicious things or things that should be alerted on, right? So right now, there's the ability to do that. There's the ability to perform network forensics, collect and store those logs that we mentioned from those endpoints, and then even really, troubleshooting things within your network, or troubleshooting application behaviors, misbehaving devices on your network. There've been tons and tons of times where myself and other folks have identified misbehaving applications or services and been able to reach out and help other folks to fix that just by using Security Onion, right? So it's not always just about detecting bad stuff, but there's a lot of overall visibility that can be gained by using Security Onion. And one of the benefits, I'll talk a little bit. So in the 1604, we used to run a version of Security Onion that was based on Ubuntu 1604. Some of you may have run that before. We've really, with this version of Security Onion that we now run on CentOS 7 and Ubuntu 1804, most of the services run in Docker containers. And what that allows us to do is really isolate those applications to their own environment, their own requirements isolated into whatever OS and other environment specific things they need, right, into that container. So, that's really useful from that isolation or security perspective, but it's also useful for minimizing those dependencies and that reliance on the underlying host. And that allows us to be really flexible whenever we're choosing to deploy security editing on a platform, right? So while we may only deploy it on Ubuntu 18.04 now and CentOS 7 now, it gives us the flexibility to not have to do as much work if we want to move the platform to another supported distribution. So containerization is really important, is a really integral part of this version of Security Engine. You may see it referred to as Security Engine 2 in some instances, which is going to be that latest version. And then in other instances, just Security Engine, since we have end of life the other 16.04 version of Security Engine. Now, as far as orchestration, there are some things behind the scenes that we do with Security Engine to help analysts and administrators make administration of that box, of that Security Engine installation easier. And some of that is, or really most of it, is through Salt Stack or Salt. So if you're familiar with Ansible or Puppet or configuration management systems like that, we use Salt to manage the configuration and the state of these security engine boxes. So, you want this box to be in its desired state, to be running a certain set of services, to be running a certain configuration, and we use Salt to do that. So, there are many also like downstream application configuration files that we use Salt in conjunction with. So, for example, Suricata's configuration file, it may have its own syntax, even though it is YAML. The IDS tools, which is our rule management application, it has its own kind of config file and it's formatted a certain way. From a Salt, this allows us to abstract that, to extract that data out of those files and be able to manipulate it at a higher level where we're not having to go into those specific configuration files, and it makes it a lot easier from the future perspective to put a web interface in front of a lot of those management tasks. So you'll see that as we go forward with security and continuing on with this development. And then overall with that orchestration, we really get that increased resilience and fault tolerance, just again, making sure that those systems are in their desired state, or the state that we want them to be in. And I want to talk a little bit about grid monitoring. Along with Salt, we have this capability to monitor our security in the grid. A lot of folks like to put agents on their boxes, maybe they have different servers they want to put like Nagios or something else on there, some other tool. We leverage this in-house by default with Security Engine, Grafana, InfluxDB, and Telegraph. So Telegraph is going to be taking all those metrics, it's going to be ingesting it into InfluxDB, and then Grafana is going to present that to us on a nice little dashboard there. So it's a great way to be able to go in from a web interface and really see how all of your boxes in the grid are doing, right? You can see events per second, right? Are you above or below a certain threshold for events per second? Are you seeing the expected network throughput that you expect to see? And maybe is there any packet loss, or what kind of data retention do you have? It's really useful for being able to eyeball that quickly and get an idea of that. So let's talk about the data a little bit. I mentioned the data a little bit with those logs that we would potentially be bringing into Security Engine, or that we could bring in. And one of those types of data is going to be that of network data, right? Data that we're collecting off the network that we're feeding to Security Engine via a span port or a tap. And this is really going to be comprised, with a bunch of different maybe subtypes or types of data itself. It's going to be things like connection data from Suricata or Zeek. They both, in Security Engine, we can log metadata about those connections using Suricata and Zeek, as well as session data. So if you've got things like HTTP, different protocols, SSL, DNS, whatever, we log that data as well. And again, both Suricata and Zeek can do that from the metadata perspective. So in this instance, Snort and Suricata, they're typically viewed as a signature-based IDS where we're only generating alerts for that traffic that it sees. In this instance, Suricata can also act as a metadata generation and generate that network data, and we can review that later instead of just generating alerts, right? It allows us for a lot more context around the actual alert and being able to see what's actually going on. The same with extracted content data. If you have files that are traversing your network, things like, executables, Excel files, Word docs. You can configure Security Onion to extract those via Zeek or Suricata. They both can perform file extraction, and we can have that type of data to associate to or to look through during our investigation. Full packet capture. So Google Stenographer, we used to use NetSniffNG. So we used to use NetSniffNG for the full packet capture, and we've moved to Google Stenographer to do that. And what we have now is a sort of indexed PCAP. It's faster to write, and it's a little bit more performant than NetSniffNG has been in the past. So, it's a little bit different as far as the files are being written on disk, but you still have that ability to review that full PCAP data. And then again, we have our network data down here below and the network packet, as you can see, and we'll see different types of data as we go along here. Another type of data, host data, right? So host data is really important. In fact, I mentioned network data. Some people only use network data during their investigations or only have that capability. Some people only have host data, right? Some people only have endpoint or agents installed on endpoints. We can have both, right? I mean, why not both? Why not more? More context is always better, right? So we can ingest certain types of host data from Windows event logs, sysmon data, audit-d, tons of stuff, right? Elastic beats is one way that we do it. WinLogBeat and FileBeat are two native mechanisms that we support to be able to tie in with all that stuff. Pick up those host logs and send those off to Security Onion, and we continue to build our context there. OS query is another great one. Not just for log collection, but also for querying the state of the endpoint. Right, so OS query has these, these tables that you can query certain status and certain details about the host, and you can do that in an ad hoc fashion from Fleet or FleetDM, and it's really a really super powerful way to kind of query across your endpoint at a given point in time, and also perform differential queries against those endpoints. So we can collect all of that data as well and bring that into Security Onion. And then we've supported OSAC and Wazoo for a long time. You can still bring in data, Windows event logs and host logs, and perform active response on hosts with Wazoo. So that is available as well. Again, there's more than this that we can bring in. These are just a few examples, but this should hopefully give you an idea of the power behind that and how you can easily pull that data in. And then we also have file data, right? So we have file-oriented detection with Strelka. And if you're not familiar with Strelka, I failed, it looks like, to include a link here, but Target, Strelka was a project of Target's and still is. Josh Liberty first started working on Strelka a few years back, and we integrated it with Security Onion since. But Strelka is a great way to take those files, that extracted content data that we've extracted from the network streams from Suricata or Zeek, and then perform an analysis on that, preliminary analysis. We can do things. It has tons of scanners. You can see things like imports, or you can generate an import hash, right? Imp hash, see entropy. You can see all the sections, right? EXIF data, all sorts of things that you can see there. And you can also use Yara to assist with detection there. So even if your IDS or your NIDS alert didn't trigger, if a file was extracted by Zeek or Suricata on the wire, and we've examined it with Strelka, and we do this automatically within Security Onion, then we can generate an alert if it matches a Yara rule that, from the file level, Strelka is able to determine. So again, it's allowing you to build those layers of detection and really be able to help with that overall visibility. And similar to the NIDS alerts, will also generate an alert in a console where you can review that for those Yara rule matches. And one other important thing with Strelka is that even if a file is in a zip file or an archive file, we can still get data about the different files in there and see what its analysis gave us. And that helps us as an analyst, by determining a certain number of things about the file before we have to go perform manual analysis. It gives us a better place to start our investigation. Now, I mentioned alert data a little bit from Suricata generating NIDS alerts, but we really have different types of alert data as well. So that NIDS, that network intrusion detection system, those NIDS-based alerts, we have those. And we also have those HIDS-based alerts, so host-based IDS like Wazoo and things that are coming from the host from things like OSQuery. We have Playbook, which I haven't discussed yet, but that'll be another type of alert data that we have available to us. And that's going to be searching just all sorts of log data, not just from one particular observer or tool. And then we also have custom alerts that if we have other data that we're bringing in, other sources, we can generate alerts from those as well and have those populated to the same console where we review the other alerts. And I mentioned a lot of other data, right? I mentioned all of the other data sources that we can bring in with CircleCityCon, bringing to CircleCityCon, and really, it's any data, right? So we have all these different types of data here, cloud data, authentication data, firewall, and syslog data, and we can enrich that data, however we see fit in those Elasticsearch and Logstash pipelines. So a lot of flexibility there as far as how we want to build context or how we want to augment our current data sets. Now, all of this data together, right? If you have all this data together and you don't know necessarily how to relate it all and how to go back and forth, maybe other than IP addresses or source IP or dest IP or whatever, there are a lot of other ways that we can tie this data together. And this is really what part of our I guess our secret sauce, or what we like to do with our data as far as within the security realm, is be able to tie all these data points together. And it makes it really useful when you have things like community ID and the Zeek UID and FUID. The community ID is going to be generated by the source and destination IP address, and then also ports, right? Source desk ports, and then protocol. And then there's some stuff that goes on behind the scenes there, and that's generated. So that's unique for every flow that we have. And whether that's across Zeek connection logs or Suricata NIDS alerts, or even WinLogBeat or Sysmon logs, right? Network connections, we can see all of that together. So if we search for that community ID, we'll see all of these logs grouped together, right? And then from there, we can go over maybe from the WinLogBeat or Sysmon log, from the network connection, we have a process ID. And from that process ID, we can go to the WinLogBeat or Sysmon file creation, process creation, all of that good stuff, right? From the community ID, we can also go over to the Zeek UID. So Zeek has its own internal identifier for connections and for files that traverse the network. And you can see this chain of pivot points and connections here where we can tie all of that together. And that's part of what makes security really, really powerful. So really great things there, and I'll demonstrate that a little bit here in just a minute. Now, I want to talk about the interfaces where you will review this data. So the first interface I'll get into is kind of the overarching interface in SecurityNN. This interface we call SOC, or SecurityNN Console. And you can see here that it's got a fair number of links on the side, and it's got a little customizable overview dashboard here if you wanted to change that out and have your own little kind of portal and graphic and data memes there. You can do that as well. So, all of that's there for you. But again, I'll talk through each of these. There's lots of different things here that we can get into from SOC. And this is really intended to be your jumping off point when you're logging into SecurityNN through the web interface and starting your investigation or starting your hunting or whatever you want to do. This is intended to be the place where you start. And I mentioned hunting. Hunt is another part of that SecurityNN console. And inside of Hunt, we've tried to capture the ability to hunt through that network and host and other types of data and be able to perform these operations to stack this data and make it really useful. And I guess it's probably not executed as best as it can be or illustrated as best it can be right here, but I'll show that in a little bit. But what this allows us to do is to search for specific types of data, or certain fields or whatnot. And then we can group that data, we can stack it and organize it by count, by certain fields. And then we can also drill into that data at each event, and we can perform different actions here, which I'll get into in a minute. But Hunt was originally developed just as a way to perform those group buys, right? To perform that free-form hunting and be able to stack that data and see the anomalies and see what isn't quite right there. Now, similarly, we have an alerts console. And if you've used Security Onion 1604 before, you may have used Squeal. There was a Squeal client, and also Squirt, which was a web-based client where we would review these alerts, right? Whether it be that network data, network alerts, or host-based alerts, or in this case, even Yara matches or playbook alerts. We would review all of that here. And you can obviously see we can group by various details here. We can search. And then we can also acknowledge these alerts. So if we don't want to see these alerts anymore, we can just click this little icon right here to do that. And then we can escalate these alerts to a case. Excuse me. So we also run the Hive, which I'll talk about in just a minute, in Security Onion, or we give you the option to. And you can escalate this alert to a case. So if you have an alert that you're not quite sure about, you've investigated it, and you want to have a senior analyst maybe take a look, or you want to save it for later, you can escalate that to a case in the Hive and then continue your investigation there. So really cool to be able to do that inside of that web interface. And we also have PCAP. Our PCAP interface is where we can pull that PCAP for a relevant event in Hunt or in alerts, and then we can go off and kind of peruse that PCAP, the full packet capture data. We can see the transcript here. There are different formats that you can put it in if you want to, if you want to see the hex as well. It's kind of cut off here, but you can just wanted to illustrate how you can kind of tweak this to be to your liking. So a lot of great stuff there. If you're looking to dig more into that event and you've kind of investigated down and narrowed down a set of events, you can start to peruse that PCAP and see the actual conversation on the wire. And then KIBANA. So if any of you have used the Elastic Stack, I know it's very popular these days, especially for security teams and for investigations and for housing that data. We do use the Elastic Stack behind the scenes for Hunt and for alerts, but KIBANA provides us, a different interface into that. We won't have that same group by capability in KIBANA, but we do have the ability to create custom dashboards. We can create some pretty dashboards for management if they want to see that, or if there are things that we search for regularly, we can do that as well, right? We can have a dashboard for certain specific things that we want to look for in logs, or maybe certain things that we may consider an anomaly, right? We can create those dashboards and then go from there. So that's a pretty cool interface that we include as well. Now, aside from the interfaces, I do want to talk about detection development a bit. So with Security Onion, we do provide a couple ways, aside from traditional NIDs, like Suricata rules or Wazoo rules, or other types of rules in that same similar domain. I do want to talk a little bit about how we can create some overarching detections and how we can really use that or leverage those tools to increase our detection coverage, maybe against a certain set of tactics or techniques that we might want to have detection against. And to start with that, I'll introduce Playbook that I introduced earlier. Playbook can generate those types of alerts, and we can view those in that alerts console. But essentially what it is it's an application where we can take things like Sigma rules. If you've heard of Sigma before, it's a generic SIM format for searching for data. So if we have a Splunk backend or we have an Elastic backend, the goal here is to have those rules be written so that everybody can take advantage of that query, so that everybody can hunt for Windows event logs being cleared, so that everybody can see the same thing in the end. And it's an awesome goal, and I really love what they've done with the project so far. And we really leverage that with Playbook. What we do is we allow you to take those Sigma rules that are shared within the community for those that we can convert to those different backends, and we can put them in here and track them as detection plays. That's what we call them. And what happens from there is that Playbook will automatically convert the Sigma rules over into the appropriate Elasticsearch query, an Elasticsearch rule for us. And we'll also automatically convert these plays to case templates in the Hive, so that if we're doing an investigation in the Hive and we see an alert come up and we merge it, it gets escalated to a case, then we can associate certain common tasks for maybe a tier 2 analyst or a tier 1 analyst to do, right? We can have those tasks defined in that case template and have that automatically applied whenever this rule fires, so that once we get an alert, we know exactly what we need to do. So the power not only lies in automating the conversion of Sigma, but also in the investigation and response phase as well. So it's super cool to be able to have that new platform and really encourage folks to use that when they can. Now, one other thing that Playbook does and that we can do within security is generate a layer for Attack Navigator. If you haven't heard of Attack Navigator, there's a link below. You can go check that out. But essentially, we can map our detection coverage to the plays that we have enabled, the Last Alert rules that we've created in Security Engine, and we can map those against the MITRE ATT&CK framework. We can review that interface. So I guess it is considered another interface, but we can review that interface to see what we've mapped our detections against. And a lot of folks get kind of caught up with Attack Navigator and trying to detect all the things or trying to fill up the chart, right, with all blue. I really want to encourage folks to focus on their threat model, right, really ascertain what that is, and then trying to figure out, from a priority standpoint, where that detection should be and where you should map and try to have coverage. So that capability is there, but just just be sure to leverage that responsibly. Now, I talked about case management a little bit. I mentioned escalating alerts from the alerts console to the Hive, and that's what I'm going to talk about here just a little bit. You can see that we have a case here about a coin miner, and we've got a little tag here just saying that it came from Security Engine, and then we've got the event details under here in the description. So if we had a playbook play, if this is fired, the original alert would fire via a playbook play, then we would have some actions or some tasks already populated here that we would need to take. In this case, we did not, but we can see that Ricky Bobby here has got some work to do, right? So so we can do that, and then again, with the Hive and Cortex, if you're not familiar with Cortex already, we implement Cortex in Security Engine as well. So if you wanted to run certain analyzers against observables that you've attached to this case, you can go off and look for IP or domain or hash information for those. And there's tons and tons of different analyzers that I'll let you review from the Cortex side as you get time. But again, really great to be able to have that functionality in there. Now, as far as deployment, I want to talk about deployment real quick. There's a few different models, a few different modes. The first is I'm going to talk about is going to be import node. And what this allows you to do is quickly and easily import a PCAP or multiple PCAPs into Security Engine. This does not run any active services. It only runs services whenever you run the PCAP through Security Engine. So if you've got an academic use case or a one-off forensics use case, or where you don't want to run the entire stack, you can absolutely do that here. And it is obviously it's going to be less resource taxing than a full-on deployment. So we have some docs that I'll mention at the end, and you can go ahead, you can review that there. But it's really great for performing that. If somebody gives you a PCAP and you want to see what it does, and you want to see all the Zeek logs and all the NIDS alerts and everything else that it generates, it's really super cool for doing that kind of thing and very valuable for that. Now, evaluation mode is going to be another mode that we have. Evaluation mode performs that live traffic monitoring, but it's going to enable everything with kind of just some base set of configurations, and it's not ideal at all for production. So please don't use this for production, but this allows you to see all of that data that we discussed in addition to that live traffic monitoring. Standalone mode is going to be a little bit different from eval mode in that it's a little beefier. It's a little more refined, I guess, as far as the way the configurations are handled. And we actually, we do have folks who use this for production use, although we don't recommend it. But if you're running it more than like 500 megabits per second, then you probably don't want to be running a standalone, right? It also performs that live traffic monitoring and allows you to configure most of those components as you see fit. The distributed mode is going to be the one that we recommend deploying SecurityNN in the most frequently. If you're running an enterprise environment or plan to, from the start, we recommend you try to start with a distributed mode if at all possible. In this mode, you can run a manager as a VM, but we really do recommend running a search node or a sensor, which are going to be performing those storage and sensing components. We really do recommend that you run those in a physical, on a physical machine. And again, all this, you can get more details about this on our Read the Doc site. So in addition to those kind of on-prem or local models, we also have some other models in which we can deploy SecurityNN in the cloud. If you have a hybrid infrastructure, where I say hybrid in the sense of on-prem and cloud, such as AWS and GCP, you can absolutely do that. You can have a sensor up in AWS or GCP and then a manager down below it on-prem. Or you can have it vice versa, or you can have all cloud. There's lots of possibilities there. And with AWS and GCP, there's that traffic mirroring that's available to you out of the box, right? We don't have to go around our ankles to try to get that mirror into SecurityNN. It's just all there. So a lot of good stuff there. And we do have an AMI in the Amazon marketplace, AWS marketplace, if you'd like to check that out as well. Now, as far as integrations, I want to talk a little bit very briefly about integrations, just really some opportunities here. Some opportunities here that you might have for integration with SecurityNN. A lot of folks like Jupyter for data analytics. So if the Elastic Stack or Hunt or KIBANA isn't working out for you, you can certainly use Jupyter for some more advanced methods. You can tie in remote IDR if you got CrowdStrike or Velociraptor. You can attempt to tie that data in and add that other functionality in as well. There's a few examples down below that I put some links to where we've done a few of these things, like with MISP and some honey tokens and all that sort of thing. So there are definitely lots of opportunities there. Just want to get the juices flowing as far as what's possible with that integration. All right, so now that I've talked through SecurityNN just a bit, I want to go through a little bit of demo and get you guys in the interfaces and see what that looks like and see what you might look at as an analyst or as an administrator. So let me go ahead and pop off of this, whoops, backwards. All right, let me get out of here and pop over. See if I can swipe. May have to do this here. Yep. We'll just minimize this here. All righty. Maximize this. All right, so right here, as I mentioned before, we have SOC. So this is the SecurityNN console, that jumping off place that I mentioned before. And we'll go ahead and jump into those alerts that we saw before, right? So we can see all of these awesome alerts here, these NIDS alerts mainly that we see here from Suricata, since we run Suricata as our alert generation for SecurityNN, right? Or at least that NIDS alert generation. And we can see different details here. Right, if we wanted to drill into one of these, there are some options here where we could include or exclude this in a search or only search for this alert. And there's some drill down functionality right now. So if we drill down into that event, we can see all of the events that were related to it. And now there's only one related to this one, so we don't necessarily see multiple here, but just gives you an idea of what we can do there. If we were to click again, we get that same kind of menu here. And if we wanted to copy any values here, we could certainly copy a value of a field or copy of the event if we wanted to. Then we can perform some additional actions. So if I wanted to go and look over and hunt, I could do that. If I wanted to correlate, I could do that. So what correlate means is that for certain types of records, we'll take certain pieces of information and we'll attempt to search Hunt or search Elastic for that data and see if we find any records that match that condition. And in this case, if it's a NIDS alert generated by Suricata, we will have a network community ID. So if we drill in, you can see the various details, the dest IP, event module, there's Suricata, right? And then some other rule data, right? Some network data that was decoded. Okay, that's kind of interesting. I see a minor.exe, right? We have the decoded packet data there, or at least some of it. And then we have this network community ID, and this is that ID that I was talking about before, where we can pivot to different events. Now, we don't necessarily have to click on this field to do the correlation, and we'll do that behind the scenes anyway. But if we go ahead and click correlate here, we can see that we're pivoted over to Hunt and where we can search more for that data. And then we see these grouped events, right? We're grouping by the event module, which is Suricata, Zeek, and Sysmon in this instance, at least in the events that it found. And then we see these data sets of events. So we can see Sysmon network connections and Zeek HTTP logs and Zeek connection records and the Suricata alert all tied together by this one community ID. And then we could go peruse that data if we wanted to, right? We could go drill down to those individual events. But in this case, maybe I want to, I'm kind of interested in the host level, right? So I saw that alert from the network level and I see this HTTP data, but maybe I just want to filter on Sysmon for now. So, all right, well, I've only got the Sysmon one now, and then we can see some details like the PowerShell.exe and that sort of stuff. So I can drill into this event here and get some more details. But if I wanted to see, even more from a correlation perspective, what other host-based events were tied to that, I can go from that process ID. So if I go on this process ID here in the process.pid, and I just search for that, then I can see all of the Sysmon, and I'll just exclude OSEC for now, but I can see all of the other Sysmon events that were associated with this network connection event. And we see a process creation event and a file creation event, right? And we kind of see the timeline here. If we look down, so we see the process creation here from PowerShell exe by Brian Phillips, and we see a file creation event here. We can drill into that, right? So if we want to see that PS1, right, the file that's being targeted to be created on disk, we can see that. And then we can see, obviously, the network connection there by that host Windows 10, WS2. Right, and then if we look, we see some details here, right? We see a destination, a host name, or whatnot. All right, but if we keep going down, we see that process creation. And then we see the resulting miner.exe again that we saw in that NIDS alert. So, being able to tie it back from that NIDS alert and drill down really into the host and trace it specifically to that Windows event log or that Sysmon event is really powerful in a sense, right? We're walking it all the way back there, right? And then if we go back, even so, another pivot point, maybe if we go back aside from the process ID, and we focus back to those network events, right? And we look at Zeek HTTP, we can see if we drill in on the HTTP there, if there was a file downloaded, usually the protocol log or the session data like HTTP will have an FUID associated with it, that file ID. So if we expand this record here, we can see this log ID, FUIDs, and we see this value here. And if we were to copy this value, then we could see even more stuff, right? So if we do that, and actually let me do a group by on event.module, we can see that I mentioned Strelka, the file detection oriented, file oriented detection, right? You can see that there, right, where it performs some analysis related to that Zeek HTTP record. And so if we scroll down and we just filter on Strelka, we'll just include that. We can see some data here. This is the largest file, or at least the largest event from Strelka that we have. We can see all of that preliminary analysis, right? We can see all of the stuff, these symbols, all of that here, right? Delete critical section, leave critical section. We keep scrolling up. I mean, there's just lots and lots of stuff here, right? All right, you've got the PE file info, right? Easy miner net, easy miner setup. So it looks like, it definitely looks like a Bitcoin miner from here. And if we wanted to take it a bit further, we could go to, if I look up here to the file, where is it? All right, this right here. So if we actually wanted to go into our executables that were processed by Strelka, this lives on disk. We can go take this file and go perform additional analysis on it. We can go carve stuff out of it, right? So it's super awesome to be able to have the capability in here. And again, I'll just kind of go walk it back over to the alert. And even if I wanted to drill down from here, again, with that PCAP's interface, I mentioned just pivoting the PCAP from an event. we can do that as well if we want to just jump straight to PCAP. All right, so we'll give it a second here. It's trying to go pull that PCAP, and I'll just refresh the page here. And look at that. Again, we saw some of this data from the network data decoded from CircleCityCon, but now we're able to see the whole transcript, right? And we're able to, if it's VXLAN and capped, if you're recording in the cloud, we can unwrap these packets for VXLAN encapsulated data. So that's super awesome, right? And then you can format it. If you want to look at it a different way, you can do all these different ways. You can absolutely do that. And then when you're ready, if you're ready, you can go download that PCAP right here and then go perform other analysis. If you want to give somebody to go look at it in Wireshark, right? Or perform, if you have an analyst VM set up and you want to run network miner on it and extract certain files, other files, you can do that. So a lot of utility there as far as what you can do from that PCAP interface, from the events and from alerts. Again, if I wanted to search, just for that host, if we go back real quick. Okay. We'll just go back from this and just trying to go back here a second and get the host that was associated. Let's go include. So if we want to take this also, right? If we wanted to just hunt, there are a lot of default queries in here where we could just hunt. You can ignore that message there, but for sysmon usernames, sysmon events, all these are built in, right? But if we wanted to perform our own freeform hunting, we can search that way. And then if we want to group by different criteria, we can do that here. If we want to do, let's see, data set, can't spell, well on TV. All right, we can group by maybe timestamp, maybe process.executable. I'll probably misspell that. Let's see. Data set, group by timestamp, process executable. All right. What am I missing here? Oh, and I'm sorry. All right, then we can do, we can see certain details there, right? There's just lots of different ways that you can go and hunt and kind of format the data how you want to see it. And that's just, again, some examples of those ways. Now, real quick before we part, I also want to show you a few other things. So I'll try to squeeze those in real quick. The grid. The grid is another way to monitor, how your security onion grid is doing. You can see health metrics here. You can see events per second if we're ingesting data, other details about the version and the name and whatnot. It just helps you to give or get that kind of overall sense of how your deployment's doing. Downloads is where we host the package downloads. If you want to install an agent like OS Query or Wazoo or WinLogB, we have some locally hosted versions here related to those latest versions if you need them. So you don't necessarily have to go out to the interwebs and get them. But you're still free to do so. Administration is where we'll just have some basic user administration tasks here. If you want to perform some certain actions or go to use a cheat sheet over here, we have a cheat sheet for security onion for specific commands for the CLI. So that's pretty useful. Then again, we have KIBANA, and then I'll dig into Grafana real quick, where I told you we can get those detailed metrics, right? We can see how much traffic we're monitoring on this link. We can see how much the management interface is seeing if we're bringing in events per second. We can see the Logstash traffic here. You can see different types of details about the environment here. And again, it's really useful to be able to do that. And I have to log on to every box and then go, type all those different commands. It's really great to be able to have that under that single pane of glass. CyberChef, if you played with CyberChef before, we include that. You can slice and dice your data, however you see fit. There's lots of opportunity there for decoding certain things, taking certain bits of data out of the packet or out of some event and then acting on that with CyberChef. And then also, I mentioned Playbook. This is where you would go in to create those detections and create those plays. And you can see we have just a couple enabled here. And if we actually go over to Navigator, we'll pop over there real quick. you can see that those plays that we have enabled, we actually have coverage for on that attack navigator layer. So again, that's helping us, map whatever we have active in Playbook to what we have coverage for. So it's really cool to be able to have that capability. Fleet DM, if you're deploying OS query, you can see all of that stuff here. You can run ad hoc queries here. If I wanted to select all of the users on this box that I have joined to here, I can do that live query. And then again, those results will be reported into Security Onion. So I'll just give it a second here. And this would be right here, this agent is connected to the Security Onion box itself locally. So we would see all of those users here. All right. Oh, I misspelled it. That's why. Can't type. TV typing. All right. So give that a second there. And we pulled back all of those users. I mean, we could do this. We could slice and dice all day with this, right? This is a very simple use case. But again, another way that we can query all of those hosts or maybe dive into a specific host without having to log in and do some other sort of connection, right? RDP into the host to get that type of data. Now I mentioned the Hive. I'll go over that briefly. Let me log in as Ricky Bobby at security.net. Whoop, that's Rick Bobby, not Ricky Bobby. All right. So we've got Ricky Bobby logged in. And again, we just have the single case, but you can add tasks, right? If you have those specifically to the case, if you don't have any already added to that template, add observables. If you want to add that, an IP address or a file, right? And say this bad, right? This bad. All right, and that'll be associated with a case, and then you can go off and perform actions on that, right? I don't have any responders or analyzers available right now, so that won't give me an option to do that, but that option is there. All right, and I think we've pretty much covered that. So as far as the interfaces, I think I'll pretty much leave it up now for questions. And if we go back to the other page here. All right, current slide. All right, and again, I just want to say thanks to all of you guys and gals for joining this talk or joining this presentation. Really appreciate the opportunity to present. If you want to reach out to me or Security Onion, please feel free to give us a shout out. I am at the Real W Lambert on Twitter, and Security Onion Solutions, we typically respond via Security Onion or the platform itself. And then we have some links down here to the docs if you want to get familiar with those, or if you want to evaluate Security Onion. We have a community support page or forum under GitHub discussions, so please feel free to ask any questions you have there as well. We also have the Security Onion Fundamentals course on YouTube. It's completely free. It helps walk you through how to get the best out of Security Onion, how to set it up, and how to really dig in and learn how to go through it as an analyst. Because while I may have covered a little bit on this presentation, there's certainly lots more that you can dig into and lots more utility that you can gain through using Security Onion. So definitely check that out. And if you if you were curious about professional services, you're currently using it or anything else, feel free to reach out to securityonionsolutions.com. That's, again, all I have today. And thank you for the opportunity to present. And I hope all of you have a great day.